So topic 3.5, question 3c, initial value problems. So we're given our dy dx equals to minus e to the power of minus x sine of x plus e to the power of minus x cos of x. So they want us to retrieve the function. So what I'll do is I'll bring my dx over and I'm going to integrate both sides. Off I go. So the integral of both sides means both of these things have to be integrated. So I'm just going to throw an integral sign in front of both of them. And away we go. So I might let no, I'll leave that. No, I'll put the minus out in front here as well, just for the crack. Okay. So the integral of dy is y. So let's have a look at our first integral here. We'll let u equals the sine of x. So du equals cos x dx. We'll do it by parts. dv equals sine of x. And the integral of sine of x is minus cos of x. So v equals, dv is equal to e to the power of minus x. Now remember, if we have e to the power of ax, the integral of it is 1 over a e to the power of ax, or e to the power of ax over a. Now our a in this case is minus 1. So it's 1 over minus 1 times e to the power of minus x. But of course it's probably just easier to write that as just minus e to the power of minus x. Alright, so let's put that integral together. So it's negative, and now the integral of that is uv, so minus e to the power of minus x sine of x minus the integral of minus e to the power of minus x cos of x minus e to the power of minus x cos of x. And I might just pop that minus there out in front, giving me minus a minus, which is a plus. Plus the integral of e to the power of minus x cos of x, which I have to integrate as well. Okay, so I'm just going to put those together. So I've got minus minus here, so that gives me a plus. E to the power of minus x sine of x. And minus here gives me another minus. Minus the integral of e to the power of minus x cos of x. And then I've got my plus the integral of e to the power of minus x cos of x. So it finishes nice and quickly here. I've got minus an integral plus the exact same integral. So minus one of the integral plus one of the integral is gone. They cancel each other out. So my integral is just simply e to the minus x times sine of x plus c. Okay, so now we just need to figure out what c is. So here they tell us y of 1 is equal to 0.3096. So the thing in the brackets is always the x, and that's equal to the y. So 0.3096 is equal to e to the power of minus 1 sine times 1 plus c. Okay, so she usually does this in radian modes, so I'm in radian modes here. So I've got e to the power of minus 1 multiplied by sine of 1. Sine of 1 and e to the power of minus 1. Okay, that gives me a value of 0.3096 rounded. It goes on as a decimal, but it's rounded. The whole point is I think it's supposed to match the other side. So when I bring minus 0.3096 over, or when I bring 0.3096 over, it becomes negative, so they cancel each other out. So I'm just left with c is equal to 0. So in that case, I don't need my c because it's 0. So my recovered function is e to the power of minus x sine of x. Now she wants to find the power under the curve between the limits of 0 and pi over 4. And she means under this curve here. So to find the area under curve, you integrate it within its limits. So our limits are 0 and pi over 4. Pi over 4 and 0. So we pop those in. E to the power of minus pi over 4 sine of pi over 4 minus e to the power of minus 0 sine of 0. Okay, so I'll work those out. So we get 0.3224 minus 0, and that's just equal to 0.3224.